If you weren't here for the earlier session, I'm Lauren. This is Robert. Robert's at the county now. I'm at the Metropolitan Water District. And this is our last tracked session on R. And we're going to show you kind of the most interactive that you can get with R. And before we get into anything, I'll just talk really briefly about what Shiny is and show you some examples of what you can actually do with it. So Shiny is just an R package. It's a way to add interactivity to any kind of output that you would get out of R. So that could be a table, a chart, a map. And it also allows you to create little web applications that you can then use to share your data analyses. And it's a really nice way of giving your audience a little bit more control over how they look at your data. So you're letting them kind of tweak things a little bit more than in, say, an R Markdown report. So in the scale of interactivity, if you're kind of thinking about, well, there's all these different tools we've learned about, let me try to give you a way of thinking about it. On the not so interactive end, we have something like an R Markdown report that just maybe has some charts and some graphs in it, but you can't really interact with them very much. Going up a step, you can have that same report, but you can make those charts and graphs using a package called Plotly, which we showed last time. And so that will give you something that's a little more interactive that looks like this, where you've still got a report, but you've got charts and graphs that you can kind of zoom in on and control a little bit. You've got the dashboards, the sort of thing that we showed last time, a little bit interactive. And then you've got Shiny apps. And these are pretty interactive, but they're not quite what you would get from like a full JavaScript kind of D3 application. And so just to kind of show the other side of the scale, this is like what you can do in JavaScript with like a D3 app, like full interactivity, sliders, bells and whistles. You're not going to get this with anything to do with R, but you're going to get something that's maybe good enough with Shiny. Okay, so I'll just show you a little Shiny application that I made a couple of years ago. I was looking at USGS has a whole database of stream flows going back decades for many, many different gauging stations all over the country. And I was thinking about different ways to visualize the stream flows. So I put together this little app where you can choose what river you'd like to visualize, or if you go to the USGS website, you can look up the stream gauging ID and enter it in yourself if you want to see a different one. And then you click this button and it actually goes out to the USGS website, downloads the data, and then creates a chart, which it then displays at the bottom. There we go. And so the chart is somewhat interactive. You can change the scale of the chart by adding joy using this slider, and the joy does go up to 11. And so what are we seeing here? You're looking at years on the vertical axis here. So this is the Colorado River at Lee's Ferry, which is just downstream of one of the two big reservoirs, Lake Powell, but upstream of the Grand Canyon and the other big reservoir, Lake Mead. And they've been collecting data at this gauging station since the 1920s. And you can see in the earlier part of the century, kind of what the virgin flow of the river looked like. When all the snowpack melted in the Rocky Mountains, you get a big pulse of snowmelt going down the river, and you get just massive flows on the river. That was a huge barrier, basically, to anyone who wanted to cross the river for, since historical times. But then in the 1960s, we did a thing, which was to build Glen Canyon Dam. And you can see what a radical effect that had on the stream flows. turning the flooding of times of yore into these very sedate kind of managed flows. So with this app then, the colors right now are pretty meaningless. They just kind of look pretty, but we can say, well, let's make the color have something to do with the total amount of water during the year. So then when the blues, you're looking at really wet years, and the yellows, you're looking at really dry years. Also right now, this is the calendar year. So January is on the left, December is on the right. But in the water field, sometimes we like to look at things from October to October, which is called the water year. So we can choose to start our graph in October instead of January. So these are the kind of things you can do with Shiny. This is more interactive than you could do with R Markdown or even with Plotly. We're changing what data is being graphed. We're changing the look and feel of the graph. Maybe we've got giving the user some control over what data they're showing. So like we can look at the Columbia River instead. And Columbia River is a really different picture because there's about 30-something dams on the Columbia. So it's completely managed flow everywhere. So it's fairly interactive, but you'll notice also it's like there's a little bit of a delay. It doesn't feel instantly responsive like a JavaScript app would feel. So there is that. So it's somewhere a little bit less than a JavaScript app in my mind. We can look at other things. This is an app that I made to look at different irrigation flow sensors in this one particular agricultural district. In this case, I wanted to share the data with some of my colleagues, but the data was these massive time series of 20 different sensors and like over a year worth of data. And if I just sent them an Excel file, it probably would have had like 20 different charts on it, and I didn't want to do that. So instead what I did was I gave them a little selector box where they could choose the particular sensor that they wanted to look at, and then it would show you the data, and you could kind of zoom in on it and look at different things that way. And then there's lots more of these. If you go to this link right here, there's a whole gallery full of Shiny things that you can see what other people have done with it, which is pretty good for getting inspiration and ideas. But so we've done this before. Here's our GitHub repository that we're going to be looking at today. So if you have GitHub set up on your computer, you can use these instructions down here. If you do not, you can do what we did last time, which is go to this address and actually download the repository. And so just as a reminder, once you go to that address, you see this green button here. And I'll put that back up in a second. Then you can download the zip file and then just unzip that somewhere convenient. Once you've finished doing that, we've got a couple packages for you to install. You can either type these commands into RStudio, or if you know how to use the package manager, you can install them that way. Oh, okay, so who has the packages installed and the repo up and running? Okay, who's still working on it? Okay, we'll wait another minute. And if you're already done, go ahead and open up example1 and look at the file that's called example1.r. Okay, so how many people are still working? Need more time? All right, so let's go ahead and look at the first example. So this is just a little R script, and I'm going to go through it line by line so we understand what it does. But basically what it does is it just makes a histogram. Okay, so here's our script. And the first thing I want you to do is actually just understand what the script is doing, because this is going to be an example of a static data analysis that we're then going to turn into an interactive, shiny app in just a moment. But for the time being, understand what it's actually doing. And since I know some of you are kind of new to R, I'm going to go through it line by line so we understand pretty well what's going on. So the first thing we're doing, we're reading in some data from a CSV file that I've put into the GitHub repository. And this is data on urban water conservation. So it's got a list of urban water agencies, and it's got some data about their water use efficiency by month for the last several years. So we're reading that CSV file in, and we're putting it in this variable called water data. And then one really nice thing that I like to do when I get a new data set that I want to explore is run some of these commands in R to kind of see what this data set looks like. So let me just zoom out here. So summary is a really good command to know because it will take all the different variables that are in the data frame and it will give you some basic summary statistics on there. So for example, the month field, if we want to know, well, what is the date range that's represented by this data set? Once we do summary, it tells us, okay, the minimum value is June 15th, 2014. The maximum is November 2018. You see there's a variable for population, and you can see what the minimum and the mean and the maximum values are there. So it's just kind of a nice way to kind of like understand what the different variables are that you're dealing with. Also, if you go over here to the environment tab, water data should, if you actually execute this, once you've run this script, which we'll do in a moment, water data is going to show up over here. And you can also look at the different variables over on the side here. And by the way, if you just want to execute a single line of code, on the Windows machine, it's Control Enter. So I just, put my cursor where I want to execute and just hit Control Enter. It'll just run that one line. If you want to run all the code, you can just, or you can also hit the Run button to just run one line. And you can hit Source, and that will run the entire script. So the unique is a way of looking at your categorical variables. So there's a categorical variable in here for the different regions that the agencies are in. So if you want to know, like, okay, what are all the values that variable could have? If you say unique water data region, it will show you all the different values. So there's, in this case, there's 9 or 10 different regions of California that are in that variable. Okay, and there's also a variable in there called GPCD, and this is kind of a term of art for water folks. It's gallons per capita per day, which is basically just a standard measure of how much water does the average person use in the average day for this particular urban water agency. So GPCD, so let's say we want to kind of better understand, well, what is the range of GPCDs that agencies in California have? This command histogram will make a histogram of the GPCD data. And you can see that, yeah, it goes all the way up to 700, but for the most part, agencies are kind of maybe between 50 and 200. This is for all of the agencies in California. What if we just want to look at a particular region? Well, we can create a variable down here called selected region, and we can say, let's just look at the South Coast region. So we can run that. that creates a new variable over here, South Coast. And I'm also going to create this variable numbins, which is how many bins do I want to show up in my histogram? And the bins are just these bars, basically, because we're going to want to adjust that later. So I'm just creating a variable for that. And then we're going to filter our data so that we're just creating a subset of the data frame that just has the South Coast region in it. And so that's what these two lines down here do. We're saying create a new variable called water data underscore filter. And we're going to set that equal to our original water data frame, but we're piping that through this command called filter, which is going to say only return the records where the region is equal to our selected region, which in this case is South Coast. So when you run that whole line, it creates this new variable, water data filter. And we should expect that it would have fewer records than our original data frame, right? Because it's just a subset. And so if we look at our two data frames here, so the original one had 22,000 records. This one has just 9,000, so that's good. That's what we expected. And now let's do a new histogram. And this time we're going to do it just on water data filter instead of water data. So this should be just a histogram of the per capita water use just in this agencies that are in the South Coast. And so when you do that, you get a different histogram. And if we change this variable, like numbins, like try changing that to like, I don't know, 15, and then run that line of code, and then rerun the histogram, and you should see the number of bins changing. And then once you've done that, maybe try choosing a different region. So maybe the North Coast. And then you can rerun the histogram and see how that changes. Oh, sorry, you need to also rerun the filter command. So this is what you might be doing if you're exploring the data, but it would be really cool to make some kind of interactive app where you can push this out to a user and they've got a really nice user interface to be able to change all these things themselves. So go in, still in that example one folder, there should be another file called app.r. So go ahead and load that up. And so this is going to be the exact same code, except it's now a Shiny app. And before I walk you through this line by line, I just kind of want to describe like how a Shiny app is built. So we'll start like big picture and then kind of zoom in slowly. So the first thing you need to do in any Shiny app is load the Shiny library, which you should already have installed. So you don't need to worry about typing any of these things now. They're all in the example code, but just to show you what the structure is like. You load the library, and then we're going to define two different parts of the app. We want to define one part called the user interface, which is going to have all of the buttons and drop downs and menus and widgets that the user is going to see. And then we're going to have a second part called the server, which is going to have all the R code that defines how you're taking those inputs and turning them into outputs like plots or data and stuff. And then once you've defined those two things, we're going to run the app by just calling this function Shiny app. We're going to say the user interface is this user interface that we just defined, and the server is this server that we just defined. So that's kind of the high level view of a Shiny app. In a little more detail now. What does the user interface look like? Well, it's going to start with some function that tells it like, what's the structure going to look like? Is it going to be a page with two columns? Is it going to be a page with one column, but maybe like a few different rows of sections? You have a few different options, and I'll show you a few later. But for right now, fluid page is just kind of a generic one that you can use. And then we're going to put some inputs onto that page. So we're going to put some sliders on in this case. Here's one slider input. And we're going to give that input a name. So if we wanted the user to be able to define their own date range for some data, we'd say, all right, let's put a slider input on there and we'll call it date range. And then we're going to also put some outputs on the page. So if we wanted a plot to be somewhere on the page, we'd put, say, plot output, and then we'd give that a name, maybe chart 1. So we're just defining where things are going to fall when the user looks at the page, where the input widget's going to be, where the output's going to be. Then here's the server logic, which tells you how those two are connected. So the way you, so we need a, sorry, server logic is just an R script basically, right? But you need some way to refer to those inputs and outputs in your R script. And the way you do that is really simple. You just say output $, whatever the name of your output is, or input $, whatever the name of your input widget is. So in this case, we're saying, all right, we put a chart up here. What should go in that chart? So output $ chart is going to be, you now need some function. If it's a plot, it's usually called render plot. If it's a table, it's usually something like render table. And then this is a normal R function inside there. So this is like what you would see in the static version of that R script that we had. So this is just the normal R plot command. In our other example, this would be the histogram command. And then here's where you define the input. So input $string date range. And that's the basic structure of it. Yeah, go ahead. Right, okay. So the reason why you do that is anything that you put inside a render function tells R, this is an output that is what Shiny calls reactive, which means this is something that's going to change when the user changes the inputs. If you don't put it inside this function, Shiny doesn't know that it's a reactive element, so it's just a static graph as far as Shiny is concerned. So anything that you want the user to be able to update or change needs to go inside one of these render functions, okay? And so then basically what happens is that Shiny sits around waiting for the user to adjust an input. And as soon as the user adjusts one of these inputs, like maybe they adjust the date range slider, Shiny then goes into the server and it looks and says, okay, anywhere where I see something that's dependent on input date range, I'm going to rerun that code and rebuild the plot or rebuild the data table. And so Shiny calls this reactivity. And that's basically how it works. So let's go back into RStudio and I'll walk you line by line through the interactive version of the water conservation app. Let's zoom in here. Okay, so first thing we're doing, of course, we're loading the Shiny library, and then we're going to define what the user interface looks like. We're going to give it a title. And don't worry about too much about the syntax at this point. Just try to understand like what the structure is. We're going to define what the page looks like. We're going to say, all right, we want a page that has a sidebar. And that sidebar could maybe have some menu options or something on it. And then here's our first input. So this is what's called a selector input. That's that little drop-down menu that you saw. So Shiny calls that a select input. We're going to give it a name. We're going to say we want this to be an input that you can use to choose the region. So we'll just call it region. Here's what the user is going to see is the label. It's going to say choose a region, and then they're going to see the menu. And then here's all the options that we want to show up on that menu. And the reason why it looks like they're duplicated here is the first one is what the user sees, and then the second one is how R treats it when they select it. So in this case, we want them to be the same because in our data frame, the regions are stored as these long strings. But what if your regions were actually coded as numbers, like 1, 2, 3, 4? It would be really nice if your user didn't have to know what region 4 was, if you could just say South Coast on the menu, but then tell R, oh, that South Coast means number 4 in the data frame. That's how you would do that. You would say like Colorado River equals 4, for example. But in this case, we don't need to do that. So we define the options in the menu. And then here's the second input. We've got a slider for numbers. We're just going to give that a name. We'll call it bins because that's the number of bins in our histogram. Here's what the user is going to see is the label. Choose the number of bins. And then here's the minimum value, the maximum value, and value is just the default. So it's going to start at 30 when they first load up the app. Okay, so let's see what that looks like. And if you, let me zoom out here. Let's just run this app really quickly. So there's a button right here, a little green triangle. It says Run App. And if you have everything installed properly, when you click that, this is what should happen.
Right now, getting the application to run.
How many people are seeing this on theirs? Okay. So we'll come around and help you for now, but for now, just kind of maybe look on with the neighbor. So here's the what we just defined as the user interface. There's a drop-down menu. Here's all the different options. Here's our input slider. Starts at 30, but we defined the minimum and maximum range. And we also defined an output, this plot output function right here. And so it also knows, okay, there's going to be some kind of plot here, but it doesn't know what until you actually run the app. But it knows there's going to be some kind of reactive plot there. Okay, so that's the user interface. Now let's go down and let's look at what's happening in the server section. So in the server section, this is just our R script. We're loading whatever packages we might need, tidyverse in this case. We're reading in that data just like we did before. The only difference is that anytime we want to refer to one of the input values, we have to wrap it inside one of those render functions like we were just talking about. So the only time we really need to refer to one of the input functions is when we're rendering that histogram. So if you remember, if we go back up here, we had a plot that we defined in the user interface called histogram plot. And so down here, we're saying, okay, I want to refer to one of those outputs, and I want to refer to the one that we named histogram plot. And then we need to have a function. And if it's a plot, the function is render plot. If it's a table, it's render table, I think. If it's a map, it's something like render map. And inside here is all the code that R is going to rerun whenever the user changes one of those widgets. So here's the line where we filter the data set according to what region is selected. And you remember last time we just had this set to like some static variable. Well, now it's going to be input $, the name of the drop-down menu, which was region. And then when we make the histogram, again, we're using that filtered version of the data set, and we're plotting the GPCD data. We're going to set the number of bars or breaks in the histogram. And again, we're going to call one of those inputs. So we're going to call the slider this time that we called bins. And then again, in the label of the plot, it would be nice to have the selected region show up. So I just put that in there as well. And so when you run the whole thing, when you change the slider, it should change the number of bins, which is what it does. When you change the selected region, it'll show you the data for a different region. So the only thing that I find really awkward about Shiny, once you kind of understand the structure, is like understanding all these weird functions and like how to specify your user interface. And honestly, every time I make a Shiny app, like I don't have these things memorized. I go and I like download an app that I made a month ago, or I go and download something off of the gallery and I use that as a template for my app that I'm about to make, because honestly, I don't want to have to remember all these weird function names. So for the user interface, just go get a template that looks kind of like something you want and then just modify that. And then down here in the server section, this is just your normal R script. You just have to modify it a little bit to make sure that your outputs are reactive and that you're calling the inputs that you want. So let's check out example 2 now in the next folder. So go ahead and load up that the app.r that's in example 2, and go ahead and run it. And what this is an app that I put together just to show you what are some of the different input widgets that you can have in Shiny. And I really like cephalopods, so I'm sorry, everything's got to be cephalopod themed. So what are some of the things you can have? You can have a button, and just to kind of show you like what happens when you interact with these things, I put some outputs over here, and these are just text outputs. So before we had a plot, but you can also just have some text that changes when the user interacts with your app. So if you click the button, it increments this output over here. And we can look at how that works in a minute. You can have different checkbox selectors. You can have a numeric slider like we just saw. You can have a menu like we just saw. Shiny even has like a very specialized date range widget, which is kind of cool. But yeah, I really like that. And you can have these radio buttons, which are just like the checkboxes, except you can only select one at a time. And this is by no means an exhaustive list. So I think. In fact, I'll just Google Shiny widgets. If you ever want to see a more exhaustive collection of these things, there's a whole gallery. So all different kinds of things, and you can actually see what the output looks like when you choose different things here. And if you want to see the code for it, you just click the button and it should show you the code. So this is inevitably how I end up coding like all my Shiny apps, is I'm like, oh shoot, what's that widget that gives you the like date thing? What's that called? I go here, I look at it, I'm like, show me the code. Ah, okay, that's what it's called. Copy, paste. Like, don't ever feel bad about copying and pasting because that's what everyone does. So if we want to look at example 2 in a little more detail, let me just load up the app again. So here's a style of page where you have 2 columns. I have one column for the inputs and one for the outputs. And if we look at the user interface, I'm saying, okay, I want a page, and then here's where I'm defining the 2 columns. I'm saying, here's the first column, I want it to be like 4 units wide, whatever the units are, kind of trial and error. Here's the header, and then I want a button. Shiny calls a button an action button. I want a checkbox input, and then you can see all the choices that you have to define when you make one of those. I want a slider, I want a select input. So, you know, it's kind of easy to remember, right? Like every input ends in the word input, and everyone has the same parameters. Like first you have to give it some kind of name. Next, you have to give it some kind of label, which is what the user is going to see. And then you have to somehow define like what the options are. If it's a menu, tell it what are the menu options. If it's a slider, what are the range of the number values that you want. And then if we go down here to the outputs, this is dirt simple. This is just called a text output. And all that means is I want you to print some value that I'm going to define later in the server section. But for now, this is just a placeholder, and we give that a name. And then going down to the server, again, this is dirt simple. We defined 4 outputs in our user interface. Here they all are. And then we just, again, we need one of those reactive functions. They all start with render. And that tells it, okay, I'm about to give you something that's going to change when the user changes the input. And then here's the different input widgets that we have, input, $, whatever the name was that we gave it. So not too bad, right? Like, would be hard to recreate from memory, but when you're looking at it, pretty obvious what it does, like once you understand the general structure. Any questions at this point? Yeah. Yeah. Exactly. I don't know. Yeah, Wesley.
So that's example one. Within your render plot function is also the word data underscore filter against the render.
Right.
Could you actually shift that out of the render plot? Run for plot so it doesn't have to run the render plot line all the way. This class that you did is one out of that.
You could not. And can you figure out why you could not? So what Wesley is asking is back in example one, in app.r from example one, in the server section, line 48, there's this we have this function render plot on line 46. And he's saying, well, why can't you just have your histogram function in that render plot function? Why can't you take this filter command out of there? And it won't work if you do. And the reason is the filter command relies on an input. Anything that relies on an input has to be inside one of those functions. And since that filter relies on input region, it has to be in there. So even though the name of the function is render plot, you don't have to just have a plot function in there. You can do any kind of data processing you want to do in there that relies on an input, or even some that doesn't, honestly. Like, I'm lazy. Some of my Shiny apps, the whole app is like inside one of those functions, basically. So example 3. We put this in just to show you a different kind of output. This is a data table output. And there's a little slider here, and so you can actually filter the data table based on what the value of the slider is. So there's a data table of cars, and there's a horsepower field, and you can say, all right, only show me cars that have a horsepower less than whatever you set the slider to, and it will filter the data table down. Also, this data table is being made with a package called DT, capital D, capital T. You don't have to use this package, but I really like it because the data tables it makes are really nice. You can sort them, you can search through them, they're paginated. You can choose how many entries you want to show. So DT data tables, you can stick them in R Markdown, you can stick them in Shiny, it all works great. So the question came up on example 3, where is this data coming from? Because there's no line to read in the data like we had before. And that's because it's using this data set called MT cars, which is actually built into R. There's a few of them that are just natively built in. And so if you just say MT cars, it shows you the data set. Yeah. Uh-huh.
How would you see the other ones?
There is a command for that. Do you know the command for that?
I mean, there's like Iris. There's some packages they come with certain data sets. Like earlier when we were showing that Star Wars data set that's associated with bflyer, ggplot has a diamonds data set with like carrots and classification of grades for diamonds because there's a lot of entries, so it's like good for visualization.
Yeah,
each
that's
package could potentially have a data set associated with it, like to illustrate what it can do.
here we go. Data, that's the function. Oh, thank you. So you can see there's actually like dozens and dozens. And these are just the ones built into R. Every package often has some data sets built into that as well. So if you're looking to just like try out things, there's lots of, you don't even have to like go get data. There's lots of stuff that's just built right in.
Yeah, there are a lot of per tutorials that have Game of Thrones data.
Oh yeah,
Which is
nice. So, you know, you can kind of play around with this stuff. The last thing to kind of talk about is how do you share these things and how do you actually deploy them? Because right now it's just running in a window on your machine. So you have a couple of different options here. If you're like a technically sophisticated developer working for a sophisticated agency, you could deploy them internally by running your own Shiny server. And that's basically open source. You can just install it from our Studio website. You can deploy your own Shiny server that will run these things. If you're working for, you know, other agencies, like my own.
And it has to be a Linux server also, just FYI.
Yeah, so if you're working for agencies like my own, you don't really have that option. So it's difficult. If you have an app that you don't mind being publicly available, there's a really nice website called shinyapps.io. And you can sign up for an account. And I can show you my account. And this is just a free platform for hosting your Shiny apps.
You can pay with Shiny apps.
Oh, that's true. You're right.
You can get password protection for it. It just depends on how much money you want to spend. If it's for an agency, then sure, like $90 a month is probably not like the worst like technical bill they'll pay. But if it's just for you, then that's probably not fun.
There we go. Let me just get into my account.
And this is actually built with Shiny also, using the Shiny dashboard package.
There we go. Okay. So, you know, here's my dashboard on Shiny apps. I've got 3 different applications running. One of them is JoyPlots. And it will give you lots of cool statistics actually about like how many people have come and run your app and everything. And so you basically get a public URL, or I guess if you have a paid account, you can password protect this. But in my case, this is public. So if you go to this URL, you will get to the app that I deployed. And so this is just the normal JoyPlot app. So, and this is integrated into RStudio. So if we go back to our application, let's run one of these. Let's run, yeah, is this the one we want? Yeah, okay. There's this little publish button up here. And before, when we were looking at R Markdown documents, if you clicked the publish button, it would say, do you want to deploy this to R pubs? Well, when it's a Shiny app, it gives you the option to deploy to shinyapps.io. And we can even try doing it right now. I'll just give this a name, like water conservation. Say publish. And it goes through, it kind of packages up your application. Sometimes it can take a minute or two to do this and then actually upload it to the server.
Depends on your dependencies, like how many packages you read in.
Yeah.
What it relies on. Yeah. Or, you know, if you're hosting it on GitHub or not. A great way to keep something going in production also is to have your master branch on GitHub where the application works and it's running. But that's the version that connects and is published to Shiny apps. and you can create a development branch where you work on changes that don't make it to Shiny apps, so that when you're ready to merge them and it's good to go, once it's merged, it's running, then you can push that version and kind of like keep a development cycle going.
So if you have a paid account on Shiny Apps and you want to deploy something not for public consumption,
Yeah, you just set it to private.
set
You
to
use
private.
RS Connect and you can set it to private.
What if you're not in
interface.
RS Connect?
I think you can still push it. I just haven't done that because I used RS Connect.
Okay.
Yeah.
But so you can't do that on shinyapps.io. You could only do this on RS Connect.
I'm not sure because that's just the way that I did it.
Okay. Yeah.
But you can, yeah.
I have not yet found a way to share something with my colleagues without, pushing it to, if it's something that I don't want to make public. I haven't found a really good way of doing that, unfortunately. You can install like your own Shiny servers internally, and you can use this thing called RS Connect, which is great if you're like a startup and you can deploy these kind of things yourself. But at least, trying to work within an agency where you've got an IT department and stuff, it can be challenging.
Yeah, you would need to pay for a Linux server, like some kind of small one that doesn't take a lot of resources.
Right.
And then install like the dependencies that you need and get those files there so that they can run.
Right. But for things that you want to be public, this works very well. And so you can see it finished. So this is now live on the internet. So anyone who goes to this address will see our Shiny app that we just made.
So the Shiny server is, we're going to like install on that VPN, that's free?
So there's an open source version of Shiny server that you can download and deploy on a Linux server that you have like on premises, or it could be a cloud server.
This one has like,
That's why I did the Shiny Apps paid version, because the IT department at the organization I worked at didn't have a Linux server and didn't want to help me. So the department paid. And because it was password protected, that seemed fine to people. You just invite users by email, they create a secure password, and then they can log in to you. And then you don't have to manage deploying applications. You have to ask yourself if you want to do that or not. So if you want to run it and do that, you can go. Yeah, you can go for it. It is fun I think it's fun to learn.
but
if it becomes a part of your workflow, like your job, it might not be fun anymore. Once the novelty phase of like I figured out how to do it, then you probably don't want to keep doing it. At least that's how it's worked. Like, oh, learn this thing, it's really fun. It's like, oh, I don't want to actually own this though. Just wanted to learn it and move on.
And the apps don't have to look really amateurish like all of mine do. You can actually create some pretty professional looking things. If you go to the Shiny gallery, there's a whole bunch of examples. And the code for all of these is open source. So you can just go download it if you want to build something that looks similar. Awesome visualization. I wish I knew what it was doing. So anyway, that's about all we have for you. Do you have anything else to add, Robert? Nice. Thank you. Yeah.